Welcome to Smartland Web TV. In this session, we will discuss heat transfer. Heat transfer means the heat energy is transferred from one place to another. There are three main modes of transfer. One is conduction, second convection, and third radiation. Under radiation, we will be discussing about the three important laws. One is Newton's law of cooling, Stefan's law, and Wien's law. First, let us discuss about thermal conduction. What is thermal conduction? If you take a metal rod and supply heat or heat it at one end, after some time you will notice that you are not able to hold the rod because that end feels very hot. So, the heat energy is conducted from the hot end to the cold end. So, when you have a rod of length L and area of cross section A, say this is the hot end theta 1 and this is maintained at theta 2, then the condition must be theta 1 greater than theta 2, then heat energy flows from the left side to the right side of the rod. Suppose you take any section here, initially when we start heating, the whole rod is in room temperature, at room temperature. So, when you start heating, every layer requires some quantity of heat to increase its own temperature. Say for example, this is 100 degrees Celsius and this is 0 degree, then the temperature of the layers have to come between 0 and 100. This will come only after a very long time, and at that time all layers will show intermediate temperature steadily. That is called as the steady state. So, when you are heating a rod, keeping one end at say steam temperature, other end at 0 degree, then when you heat it for very long time, every layer in between these two will attain a constant intermediate temperature, and it will remain constant as long as we supply the heat. This is known as steady state. In steady state, the quantity of heat crossing any section will be constant. In steady state, the quantity of heat crossing any section will be same. So, Q is the quantity of heat per unit time, per unit time. So, actually it is Q energy by 1 second, that is the meaning. Then it is found that Q is proportional to, or we will write Q by T, quantity of heat, T time. Then Q by T proportional to area of cross section and proportional to the difference in temperature, and inversely proportional or the temperature gradient. So, the quantity of heat conducted per unit time is proportional to area of cross section and the temperature gradient. This is called as the temperature gradient. Then we can write Q by T equal to K A theta 1 minus theta 2 by L, where this proportionality is constant K is called thermal conductivity of the material or coefficient of thermal conduction. So, K is known as the thermal conductivity of the material. Let us now find the unit and unit for K. So, what is Q by T? Q by T is watts. This is meter square. This is Kelvin, capital K, and this is meter. So, the unit of K is watts per meter per Kelvin. So, the unit of thermal conductivity K is watts per meter per Kelvin. Different metals have different thermal conductivity. Metals are good conductors of heat. So the main mode of transfer of heat in a metallic rod is by conduction. Now let us consider this equation Q by T equal to Ka theta 1 minus theta 2 by L. Now let us compare this with the flow of electric current, which is due to the flow of charge per unit time, and this is equal to V by R, Ohm's law. Now only if there is a potential difference V, only if there is a potential difference V, current can flow in a conductor. In a similar manner, only if there is a temperature difference, heat can flow in a metallic conductor. So we can compare, this is heat flow or thermal current. We can compare this with current and write this as thermal current. Thermal current will flow only if the difference in temperature exists. So thermal current is equal to theta 1 minus theta 2 by thermal resistance. In the place of electric resistance, we have thermal resistance. So rewrite this equation, rewrite this, keep only the difference in temperature, so it will become L by Ka. So the term L by Ka corresponds to thermal resistance. So the term L by Ka corresponds to thermal resistance. So it is L by Ka. Okay. So this is analogous analogy to the flow of electric current, electric resistance R. Now analogy we define the thermal resistance.